Hello friends, in this video we are going to see about count sort. This is one of the sorting algorithm in data structure. We know there are many different sorting algorithm are there in the data structure like merge sort, quick sort, selection sort, insertion sort. In all those sorting algorithm, we will be sorting it by comparing one element with another. But the speciality of count sort is there is no comparison in going to happen in count sort. Instead, what we are going to do is we are going to count the distinct key element in the given input array or in the given input element by which we are going to do the sorting. Okay, so why we want to do this kind of count sort is generally whenever if you want to do any other sorting using other algorithms, the time complexity is n log n. We can say big O of n log n. Okay, and but if you see the time complexity of count sort, we can reduce it somewhat linearly like big O of n. So let's see how we can able to do this. And when you speak about other algorithms like quicksort or merge sort, the time complexity is more, but the space complexity is less. But if you see in the count sort, the time complexity is reduced, time taken is reduced, but the space is little increased. So when we increase the time, space is decreased, and when we decrease the time, space is increased. This kind of scenario is said to be as time and space trade-off. Okay, I hope you got it. Now we are going to discuss how we can able to do the count sort. Let us take an example quickly. So here if you see, this is an example taken to do this count sort. And if you count the number of elements in this given input array, if you see the n value is equal to 10, which means 0 to 9. So the total number of elements is 10. And then we have to find a k value. K can be given as with any name. And what does this k specifies? The k specifies the range. From what range to what range the elements are in. So how will we find it? You have to find the maximum element or maximum value in this array. If you see the maximum element in this array is 7. So we can say the range will be starting from 0 and it goes till 7. So 7 says the maximum value. If you see in this array, the maximum element is 7. So k value is 7. Right, so the total input element is 10 and the k value, the maximum value in this input value, this is 7. Okay, now what is the next thing we have to do for this count sort is we have to create another array that is called let us name this count array. And what will be the size of this count array is the maximum value, the k. So k should be the size. So here it will be starting from 0 and goes till 7, which means the size will be like k plus 1. So that will be the size of the count array. So we have to initialize this count array initially with 0. What is the purpose of this count array is this will be counting the distinct value in this input array. For example, 2. How many times 2 comes? That count will be updated here. How many times 7 comes? That count will be updated here. How many times 3 comes? That count will be updated here. So this count array will be having the count of the distinct element in this input array. So how will we do that is, first what it will do, it will take first element from this input array. Let us name the input array as A. Okay, let us name this input array as A. So we will be naming this index as I. So initially we are starting from the I, that is 0. So what is there? 2. So 2 will be taken as an index in the count array. So this is the index, right? 2, that is the index in the count array. And here we have to increment the value. What is the meaning of it? We have found 2 for first time. So increment the value. Now we are going to increment the I value. It came here. So what is the value? 7. This 7 becomes the index of this. So here it will come. And here we have to increment it. So now it become 1. And then what is the next? You have to increment the I value. So it become 3. So now this 3 become the index of it. And we have found the 3 for one time. So here, so it will be incremented to 1. And then 4. So here now we have came here. 4 become the index of this count array. So we have to increment this value to 1. And then we are finding the next incrementing the I. So it is 3. So come to the this place and increment it. So already we have found 3 for one time. So we have to increment now. It become 2. And then 0. So 0, go to 0th index here and increment to 1. And then increment the I value 4. So here go to the 4th index and increment it become 2. Now go to the next value 3. Come to this index value 3 and increment it, it become 3. And finally the last value in the input array 2. So come to the index value 2 and increment it. So we done with the counting. So what does this counting tell to us is, we says 0 is occurring for one time, 1 is occurring 0 times, 2 is coming for 2 times, and 3 is coming for 3 times, 4 is coming for 2 times. You see here, 4 is coming for 2 times, and 5 is not coming anytime, 6 is not coming, and 7 is coming for 2 times. Right, we have missed somewhere. So this count array specifies to us how many times a particular value is there in this input array. So this 0 to 7s are the elements of this input array. So that is taken here as the index of this count array. Right, so that is the next step. So let us convert this to coding. So if you convert to coding, how does it occurs? So let's say for loop. So in the input array, we started from 0 and we move till less than n. Since the n value is 10, but the array starts from 0, so it goes till 0 to 9. So less than n, then I plus plus. And now what we do here, so first we read one by one element from the input array. So if our array name is A, and we'll take one by one element. So starting from the index A of I. So now this becomes the index of whom? Count array. So for example, if I take 2, 2 becomes the index of the count array. Then what we did, we incremented the value which was already there, right? So we have to increment it, let's say plus plus. So using this code, we can achieve and find the number of element or number of times this key values or this values are coming inside the input value. Okay. So then what we have to do is, after that, we have to update this count array. Why we want to update this count array is, now by this value we can understand how many times 2 is coming, how many times 3 is coming inside this input array. That we know now. Now what we want to know is, we know 3 is coming for 3 times, but we want to know in which index position we have to place this 3. So which are the 3 index positions this 3 is going to take? For example, 7. We know 7 is coming for 2 times, but we want to know in which are the index 7 is going to be placed when we do the sorting. For example, if you see here, this is the sorted array after we do sorting. So just to make you, from this we know that 0 is in the position 0 and 2 is coming accommodating this 2 index position, right? And 3 is taken this value starting from 3 to 3, 4, 5, and 4 is taken this index value which is 6 to 7, and 7 has taken the index value 8 to 9. So to in which index positions we want to place this element after we sorting, we want to know that, right? For that, we are going to update this count array. Let me teach you how to do that. Okay. So we are going to update this count array. We are not going to create any new array, but we are going to update in the same array. So how we have to do is, so let me quickly redraw this count array, same array, but I'm redrawing it. Okay, so 5, 6, 7. So what you have to do, the first value we have to keep as it is, because we know 0 is coming for one time, that we know. And from the second value, what we have to do it, this, how to find this particular value is, this we have to do is take this value and add the previous value with it, right? 0, what is its previous value? 0 plus 1. So that is 1 itself. Okay, 1. And then how to find the value in this location is, what is there? 2, available value is 2. 2 plus the previous value is 3, right? Then this value, what is the available value there in that ith location is 3, and we have to add it with the previous value, so it becomes 6. Then 6 plus 2 is 8. 8 plus 0 is 8. 8 plus 0 is 8, and 8 plus 2 is 10. Right, which means first 0 is going to accommodate one place and no 1 is there, so it is the same index position. After that, we have to taking 2 plus 1, which means the next 2 positions we are going to take this, and the next 3 positions we are going to take it. Since it is starting from 0, it will be 1 value decremented. Okay, so now this updated count array help us to understand in which index position this value need to be updated. So now let us convert it to code in the same way. So here, how will we update as a code? Now the k value ranges, the count array ranges from 0 to k, right? So, and as I said, the first value need to be keep as it is. So here we are going to start the value from 1, because 0th value we will not update. So we are going to start it from equal to 1. So since we are going to start from 1 and we have to go till k value, right? So k value is what? 7. So we have to move till the kth value, that is still the 7th index position. So I have to say I less than or equal to k, then I plus plus. Then what we did here is, we have to update this count I. So we have to update this count array in the ith position. How will you update? Say for example, if I want to update this second place, I'll take the value from the second place and I will add its previous value also, right? 2 plus 1 is 3. If I want to update this place, how will I do? I'll take that particular value and add its previous value. What is the previous value? 3. Because this is what the updated value, right? So that what we have to take. So 3 plus 3. So what you have to do, count of I equal to count of I, that particular value plus its previous value. So how will I take? Count of I minus 1. So the ith value and its previous value, right? So this is the code to update this updated count array. So this particular value is updated by taking this particular value and its previous value. So 3 plus 3. So this 2 values. So to update this. And if I want to update this particular place, then I'll take this 2 along with this previous value. So 6 plus 2. So now this updated count array help us to understand the index position of this newly updated array. Okay. So now we are going to take, and now we got how many times the particular value is coming, and then also after that we also know the index position of each and every values. What is the index position? 0, 1, 2, 3. Okay, using this index value we are going to arrange it now. For that, let us take another array. Say let us say B array. So we need to take the same size as that of the input array, right? It will be ranging from 0 to 9. 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. So now we have to, we know all the we got all the requirements. So based on this count array, we are going to now arrange all the elements. So now we have not compared any value thus far. We just counted all these things, right? Now to do this, what we have to do is we have to start from the end of the array. We are not going to start from here. We are going to start from the rear side, back side. Okay, end of this array. So now what we have to do is first to take the 2. The last value in the input array is 2, right? So now 2, this 2 become the index of the count. Okay, the 2, what does 2? 2 become the index of this So we have to come to that to particular position. And then since we have started from 0, no, we are starting from the 0th index. So we have to subtract 1 from that. So 2, this is what the updated count array. Here we have, hereafter we have to use this array only. So start from the last value 2. Let us use another color for it. So I'm going to start from this place 2. So go to the second index and subtract 1 value from it. So now it become 2, right? Now what we have to do, go to the second index position in B array. So go to second index position in B array and place this value. So I'm going to place this 2. Okay. Then go to the next position, 3. So what will you do? This 3 become the index of the count array. So you will be here. And in that, what we have to do, we have to find the index. This is the index. So subtract 1. So it becomes 5. Because since we have started the index from 0, we are subtracting. Then only it will be the correct value. Okay. And 5. And now what we have to do, this 5 is the index position for placing this 3. So go to 5 and place this 3. Okay, now come to the next value, that is the 4. So 4 become the index of this, come here and subtract 1 because we are started from the array started from 0. So 7, this is the correct index position now, right? So go to 7. So this is 7, place 4 there. Okay, so that is the interesting thing here. This updated count array gives us the index position where to place this 4. And now what is the next thing? 0. So what you have to do, go to the 0th index place. And what you find there? 1, subtract 1 from there. When you subtract, it becomes 0. So 0 become index of this. Come to 0th location and place 0 here. So we've done this. Go to the next value, 3. So 3 become the index of this. So come to 3 there, subtract the value. So it become 4. So go to the 4th index and we have to place the 3 there. And then what is the next one? 4. Come to the 4th index position, subtract 1 value from there. It becomes 6. So come to the 6th index position here and place the what value? 4. So these are the values need to be placed and it says the index. That's it. Now come to the next position, that is 7. So come to the 7th index position in the count array. Subtract 1 from that, it becomes 9. So 9 is the index position where you want to place 7. So come here 9 and place the 7. And then what is the next thing? 3. So come to the 3rd index position here. Subtract 1. So it becomes 3. So come to the 3rd index position and place the 3. Next is 7. Come to the 7th index here and then subtract 1. So it becomes 8. Come to the 8th index and place 7. Finally, the last value come here to become the index of this. So go here and subtract 1. So it become 1. Go to the index position 1 and place this 2. So now we can see here we got the updated as well as we got the sorted array. So this is the input array A. This input array is now sorted and it is placed in the array B. Okay, so now I hope you have understood this updated count array help us to know the index. Okay, and one more thing is why we are coming from the back side of the array is we want to maintain the position. For example, if you see 4 is coming for 2 times. So this 4 should be placed in the position, the exact position should be to maintain the stability. We want to maintain its exact position, which means 4 should come, this 4 should come this side. Then only this 4 should come here. Even though both are 4, but we have to maintain the place, right? This 4 should come first time in this. This 4 should come second. And if you take 3, we have 3 3s here. 1, 2, 3. So, but this 3 should be come at the last. Next 3, this 3, then only this 3 should come, right? So, to maintain this stability, the places in the correct order, this 3 times the 3 is coming. The positions of this 3, order of this 3 should not be altered to maintain the stability. That's why we are coming from the back side of the array, which means starting from the back side, and then we are updating it in the new array, and we got the sorted array, right? Hope you got it. Now we are going to code it, okay? We are writing the coding part of this. Again, it is easy. So what we did is, we are going to use the for loop. So we are going to read every time from the input array A, and we are reading first. We started from the back side of the array. So we have to say n minus 1. And then we have to go till the 0th value, right? Until it is greater than or equal to 0. And every time we have to decrement this value, right? First, the backside of the array is starting from the index 9. Then it should become 8, 7. So we have decrementing it. Then what we did, we took the value from that place. So how to take the particular value? So let's say we are going to take this a of I value. That only we are going to put it in the B array. But in which place we have to put that, we have to know, right? So what we did, we are going to take a of I. A of I means n minus 1. N is 10, minus 1 is 9. So in this place, we are going to take that value. That become the index of whom? This become the index of whom? Count array. Okay. And then what we did in the count array? In the count array, we decremented the value because we know that the array is starting from the 0th index. And after we decrement, for example, here initially 10 was there. Then we decremented, become 9. This 9 become the index of this B array. Then we came here and we placed the value of this 2, right? That is A of I. So that become the index of B array. Right? So when we will be coming to this 9th location and we will be, so for example, 2 means we came to 2 and we came, we decremented, it became 2. Then we went to 2nd index here. So that become the index of the B array. And in that place, we kept this 2. So that is A of I value. That is why A of I value is kept in the B array where we kept first this 2 become the index of count array. In the count array, we decremented. That decremented value become the index of B array. And in that position, we kept the value A of I. Right? We have now converted this to code. Finally, what we have to do is, we have to copy this B array to the original A array. So for that, how we can do? We can use another for loop starting from 0, I less than n, I plus plus, and we are going to take the B value, I value, and that we are going to copy back to the original array A of I. So it's just a copy. Taking the B value, that is, this value need to be taken and updated in this place. Second value take and update in this place. So just copying the B array to the original A array. So now we got the updated A array. So we have sorted. We didn't do any comparison. We just by doing some counting and we did the sorting. Okay. So I hope you got it. Now what we have to do, we want to find the time complexity. So how will we find the time complexity is, for example, how many times this for loop run? This is running for n times, right? And this is running for k times. And this for loop is running for n times. And this finally we did a copy, right? This for loop run for n times. So when we add all these things, n plus k plus n, right? So here we can n time, n, then k, n. So if you see here, we'll get 3n plus k. But we know whenever we find the time complexity, we'll be taking the higher order. So, and we'll be ignoring the constant. So it will be like n plus k. So we can say big O of n plus k, right? So this is the time complexity of, okay, time complexity of this count sort. And even sometimes we can even ignore it and we can take as big O of n. Okay, so this is what the time complexity, and you can see that when compared to the other algorithms like big O of n log n, we have decreased the time, but the space is increased, right? So as I told you earlier, whenever we decrease the time, space may be increased. How we can say we are using a count array, then we are using a B array, right? So we are decreasing the time, but we are increasing the space. This event is called as time-space trade-off. Hope you got it. But if you see, so we are decreasing the time, that is an advantage. But there are some problem with some of the disadvantage of count sort is we can use count sort only for the positive values. We cannot use the count sort for negative values. Okay, the first thing. So if we discuss about the disadvantage of this count sort means we can say this count sort will be working fine for only positive values. It won't work for negative values. Also, it won't work for the floating point value. Okay. That is the one thing. If you want to do work for the positive value, then we have to do the normalization and all these things. And the second value is, say for example, if we have 50 elements in an array, okay, but the range of the value, no. So for example, if you see here, there are 10 values in the array and the range is 0 to 7. It's the same way if you consider there are 50 elements in an array, but the range is, let us take us 1000. So what will you do when you make a count array? We will make a count array. This is a k value, right? We will make a count array with the k size, k plus 1, right? 0 to k plus 1. So 1000 places you will allocate. But how many elements are there? Only 50 elements will be. Out of 1000 k size count array, we will only allocate 50 elements in that. So remaining 950 spaces are empty. So we are wasting some time when the k range is greater than the size of elements inside the input array. So this is one problem. So it should not, this k value should not be greater than the size of the input value. Okay. So for example, here input size is the input array size is 10 and the k value is within that, right? Then it will be good. In that case, count sort is better. But when the k value means the range is more than the size of the input array, then space may be wasted. So this is the another drawback of it. So this is a problem, but anyhow, we could able to decrement or decrease the time complexity. So that is the specialty of the count sort. I hope you got it. Thank you. God bless you.